Hello everyone, this is me Arun Panchal and I'm here with a project titled Innovative Strategies for Multiple Disease Prognosis Using Machine Learning. We are group number 3 of Computer Engineering Department of Rajiv Gandhi Institute of Technology, and this project is done under the guidance of Dr. Shalmira Rathod ma'am. This landing page harbors an installation guide since it is hosted on GitHub. We have listed features of our project as well. It is very fast and light since we've incorporated best software practices to construct and implement our models. We have enhanced readability in the code and we have enhanced UI and UX. We have used credible datasets. We have verified the datasets from leading doctors and surgeons across India. We have also prepared extensive documentation for our website in order to help the users or patients understand the system better, how it works and how it proceeds. So let's take a look at the project that we've made. We have hosted the project on Streamlit and we've taken 3 diseases into consideration. One is diabetes, then heart disease, and then Parkinson's. So let's consider diabetes for instance. We've made a form which will take inputs from the user, and based on the data provided by the user, that data will be fed into the system and prediction will be carried out, and the eventual result of that prediction will be displayed on screen. So the features that we've taken for the prediction to happen are number of pregnancies, glucose level, blood pressure level, BMI value, insulin level, skin thickness value, diabetes prediction function value, and the age of the person. I've just added a few values over here to just showcase one example, and the form is validated as well. So if anyone enters any invalid values, then an error would be prompted. So just showing that you have to rectify the value. And once the prediction button is being clicked, a dialog box is displayed which says suggestions and inputs from our associated doctors. Now, this is the innovative step that we've taken towards prognosis, is somewhat to merge software-based prognosis or machine learning-based prognosis along with the extract of years and years of experience of surgeons and doctors, what they've learned and what they've come across these years, and sort of to merge these two worlds into one prediction system. So that's what we've strived to do, and we've sort of incorporated the doctor's opinion into diabetes as to what they consider, as to what they've seen across the years, that what are the conditions for a person being pre-diabetic or diabetic or non-diabetic, and this goes for all the diseases. So, and this entire thing is being verified. We've consulted the doctors as well. So apart from that, the result will be printed that the person is diabetic, having an ML model accuracy of 78.33%. So this is the entire system that we've made. Same goes for heart disease prediction, whereas the features of course are different, and same for Parkinson's disease as well, wherein the values have to be entered and then prediction will be carried out. Now let's take a look on the documentation that we've prepared for this project. After installing the starter files of this project, there are certain dependencies which have to be installed. So we have given command for the same. Then we've added sections about the diseases that we've taken for the project. So there's an about diabetes section which sort of has information about the features that we have used for prediction, so as to let the user understand the factors better and understand the system in a much more simpler fashion. Same goes for heart disease, whereas we've made 3 columns: factors, description, and the normal range of that feature. Same goes for Parkinson's disease as well, and we've added a section as to how the prediction is being conducted, starting from the data collection and pre-processing, followed by feature selection and engineering, then model selection, model training, model evaluation, and then prediction being carried out. And after the prediction, result presentation is being done, and then model deployment is being carried out. So this is the documentation so far that we've prepared, which sort of lets the user understand the entire system better. We have also prepared a report on our project. So let's take a look on the contents of the reports first. As you can see, firstly, we've written the abstract, then comes the introduction to the project, and followed by the literature review, then the proposed system, which contains analysis and the details about hardware and software, design details of the system architecture, the methodology, and the procedure. Now what we've done is we've divided the entire project basically into 2 semesters, whereas in the first semester we covered the first 3 aspects of software development, which were requirement gathering, planning, and analysis phase. So Last semester, we covered the first three topics. And in the current semester, which is in the next semester, we focused solely on the implementation part and analyzing the results and framing the conclusion and the future work, along with listing down the final number of references. So this is the content of the entire report. These are the list of figures that we have incorporated into the report. There are in total of 13 figures. These are the list of tables, in total of four tables, I'm sorry. These are the list of algorithms. We have used two algorithms, logistic regression and support vector machine. We have also used random forest in order to visualize the results of the prediction. So we've used one more algorithm, which is random forest algorithm. Now let's take a look at the GitHub repository for this project, where the entire code base is currently uploaded. So the dataset folder contains the datasets. The collab files to train models folder contains files which harbor the entire ML model. And app.py is a driver file which is linked with Streamlit, and it contains the front-end code as well of the entire project. The requirements.txt file contains a list of dependencies which can be directly installed using this command that we saw, npm install -r requirements.txt. So this is the entire GitHub repository. It's public. Anyone in the world can access or maybe contribute to this repository and make the system even more robust. We have also prepared a PowerPoint presentation on our project. So let's take a look on that. So this project explores the application of machine learning algorithms to predict multiple diseases based on comprehensive patient data. Leveraging a diverse data set and sophisticated models, the system offers reliable disease prognosis using machine learning algorithms such as SVM and logistic regression. Through robust predictive analytics, this project contributes to enhancing healthcare outcomes and preventive care strategies. So we know in recent years, the healthcare and medical industry has witnessed a remarkable transformation driven by cutting-edge technological innovations. What once seemed like science fiction, a scenario where individuals could receive medical prognosis from comfort of their own homes, is now a tangible reality. This paradigm shift, often referred to as prognosis from home, has become possible through the convergence of state-of-the-art machine learning techniques and the availability of vast and diverse healthcare datasets. This is the literature survey that we've conducted. Here is the title of the paper, the authors, implementation technique that they've used, and the accuracy of their model. So we've included almost 15 papers, journals, as well as magazines into our PowerPoint presentation. Next comes is the problem statement. So we know many of the existing machine learning models of healthcare analysis are concentrating on one disease per analysis. So if user wants to predict more than one disease, he cannot. So that's the problem that users were facing, along with a decreased credibility and accuracy in healthcare models, because something like healthcare has to have a doctor's opinion attached to it. And in all the papers that we've reviewed, nobody had integrated these two worlds into one software system. So that's why we have done that in order to increase the credibility till at least some extent greater than just pure software-based prognosis. This is the system architecture. We also included random forest here, since I said we have used random forest in visualization of data. Whereas firstly, we have the disease data set, which is being pre-processed. We've conducted one hot encoding and other such pre-processing techniques, and we've divided the data set into training set and testing set. And once that's done, the entire user input is being taken and the entire prediction is being carried out. These are the dataset sources that we've taken from. The diabetes dataset is taken from lab surveys from various locations. The heart disease dataset is being taken from databases from Cleveland, Switzerland, and Long Beach. And Parkinson's disease dataset is being taken from lab surveys from various labs. These are the hardware and software requirements. This is the steps for the diabetes ML model, and this is the output that we get for diabetes prediction. And again, these are the inputs and suggestions from the associated doctors. Same goes for heart, and same goes for Parkinson's. This is the summary, and these are the references. Thank you.